Permutations. A permutation is an ordering or an arrangement of objects in a set. And oftentimes we want to be able to figure out how many ways we can do that. In order to figure that out, we need the fundamental counting principle or the multiplication principle that we've looked at before. For example, suppose you have 5 books and you want to know how many ways can I arrange these on a shelf. Well, you have 5 books available for the first position, and then once you've placed the first book, you now have 4 books left for the second position, and once you place the second book, you'll have 3 books left for the third position, and after you place that one, you'll have 2 books left for the fourth position, and then finally 1 book left available for the fifth position. To find the number of ways we can do this, we multiply these numbers together, because we can do the first task 5 ways, the second task 4 ways, etc. So the number of permutations of the 5 books, we would write it like this. It's a capital P with a lowercase 5 in front and a lowercase 5 in back, or a capital P with parentheses like an ordered pair, 5 and 5 inside. It's 5 times 4 times 3 times 2 times 1, which you know is 5 factorial, or 120. So this comes from the counting principle. In general, if you have n objects in your set, then the number of permutations will be n factorial. So that's a general rule you can use whenever you're trying to arrange all of the objects in the set. Now, if you have 6 people and you want to seat them around a table, well, you can do that 6 factorial ways, which is 720. If you have 8 people and you want to figure out how many ways you can line them up, well, that's 8 factorial ways. 8 people are available for the first position, times 7 who are available for the second, times 6 who are available for the third, and so on. 8 factorial is 40,320. If you take a subset of R objects from a set of N objects, then the number of permutations would be called NPR, like this. And that would be N, the number of objects you have available for the first position, times N minus 1, the number you have available for the second, times N minus 2, and so forth, down to N minus R plus 1. And so you'd have 1, 2, 3, up to R objects in here. So you're going to have R numbers here multiplied together, and this is what you're going to be doing. Now the problem is, if you're working with very large values of N and R, this is a very cumbersome way to think about it, and it's a lot easier if you multiply this by N minus R factorial and then divide by N minus factorial. This whole expression right here equals 1. And when you do that, you get this for NPR. It's the same expression from up there as we had, and we now have N minus R factorial up on top, N minus R factorial on the bottom. But this top expression is just N factorial. So you could simplify that down, and the number of permutations of N objects taken R at a time is N factorial divided by N minus R factorial. So it's a pretty simple thing, pretty simple formula to work with. Here are a couple examples. If you want to find the number of ways you can arrange 4 objects drawn from a set of 10, that would be 10p4. And that's the number of permutations of 10 objects taken 4 at a time. It would be 10 factorial divided by 10 minus 4 factorial, which is 10 factorial over 6 factorial. It's 5,040. If you want to figure out the number of permutations of 18 objects taken 3 at a time, that would be 18 factorial over 18 minus 3 factorial, which is 18 factorial over 15 factorial, or 4,896. Now you can do this on the calculator. Calculator is set up to do this pretty well. On a TI-84, what you do, if you want to calculate one of these, you just type the first number. So in this case, we do 10p4, type the 10, and then go to the math button, which is right here, and then go over to the PRB menu. You can scroll that way and then select number 2 from the list, and then type in the second number here, which is 4, and the calculator will give you 5,040, just as the formula gave us. If you want to do 18 NPR 3, you can actually scroll to the left and get there a little bit more sooner, and then select number 2 from the list and then type the 3. Calculator will give you your 4,896. So the calculator is set up to do this. It's very simple to work with. Here are some examples where you can figure these out on the calculator yourself. Okay, so here are the directions for doing it, and you can do those 5. Pause your video, find those, and then come back. Okay, welcome back. 15p8, the number of permutations of 15 objects taken 8 at a time is quite large. 259,459,200. Yes, these numbers can get quite big. When you're working with factorials, that tends to happen. 12p5 is 95,040. 16p7 is 57,657,600. 20p4 is 116,280, and 14p6 is 2,162,160. But when you're working with factorials, these numbers can get quite large, and if you try to do these things by hand, it's pretty difficult to do. So having the calculator with these functions built in is very, very useful.